Okay, in this problem we want to find the pressure exerted by this cylinder if it stood on end. So if we stand it on that end there, what pressure will it exert? We know that the density of this particular liquid or material is 45 grams per centimetre cubed. I know that the radius of the end of the cylinder, so that's this radius, the distance from the middle to the outside, is 14 centimetres, and that the length of the cylinder from here to here is 35 centimetres. So I've got to find the pressure exerted if it's put on end. I know these formula to find the volume of the cylinder and the area. So you could pause this video at this point and see if you can work it out. And I'll go through the solution below step by step, so you can stop at any point and see if you can carry on to get the answer. So the first thing I do was to write down what the formula is for the pressure. It's the force over the area of the end. I'm not given the size of the force or the area, so I'm going to have to work out these two things to be able to do it. So the first thing I do is think about, well, what is the force? That's the weight. And the weight is mass times gravity. And I know that G, it's always the same number, G equals 9.81 newtons per kilogram. And the fact that that's in kilograms means that when I get my mass, that needs to be in kilograms, so I can work out the weight. I don't know the mass, but I do know that the mass is given by the density times the volume. Now I'm getting somewhere because I know the density is 45 grams per centimetre cubed, and I can find the volume because the volume is given by this formula here, and that's pi r squared times the length. And I know the radius, it's 14, and I know the length, it's 35. So the volume is pi r squared times the length. So a bit complicated, but what I'm going to do is do this in reverse to find the force. So let's just recap quickly on this force. To find the force, I need the weight, because the weight is the force. The weight is mass times gravity. I know gravity, so that's okay. But I don't know the mass. But the mass is the density times the volume. Well, I know the density, so that's okay. But I don't know the volume. The volume is pi r squared times the length. And I know the radius, and I know the length. So that means I can work out the volume. Knowing the volume, I can work out the mass. Knowing the mass, I can work out the weight. And that means I know the force. So now I know how to find the force. What about the area? Well, the area, that's a bit more straightforward, because if I put it on the end of this cylinder on its end, the area is pi r squared. And I know the radius, and so I can work that out. The radius is given by, is up here, it's 14. So I can work out the area, that's not so bad. It's just this weight or this force that's the problem. So see if you can work it out from there, and again I'll put the solution below. And what I'll do when I work out the solution is to do this in reverse. I'll work out the volume first, then the mass, then the weight, and then I work out the area, and then I can find the pressure. So first of all, the volume. Write down the formula, it's pi r squared times the length. And then I put in the numbers. It's pi times the radius. Well, what's the radius? That's 14. Squared times the length. What's the length? 35. So that's what I put into my calculator, and that will give me the volume. And the volume turns out to be, so that turns out to be 21,551.3 centimetres cubed. I've just held on to quite a lot of the accuracy. I'm going to round my answer at the end. So that's the volume. Now I work out the mass. So the mass is the density times the volume. Again, write down the formula and then put in the numbers. The density is 35. Oops, sorry, wrong question. The density is 45 grams per centimetres cubed. 45 grams per centimetres cubed. Times the volume, which we've worked out as 21,551.3. The density is in grams per centimetre cubed, and my volume's in centimetres cubed, so the units are correct. So I work out what that is, and this will give me the mass, which turns out to be 969,808.5 grams. That's the mass. But remember, I want the mass in kilograms to find the weight. So that mass dividing by 1,000, which means move the decimal point back 3 places, is 969.8085 kilograms. So that's my mass. Now I need to find the weight. Weight is mass times gravity. So that equals 969.8085 times 9.81, which is gravity. And so that gives me the weight, which is 9513821.4, near enough, newtons. So that's the force. The weight, which is the force. So that's the force that's going to go into my pressure calculation, the weight. Notice I've held on to quite a lot of accuracy. Again, I'm going to round at the end. So now I want to work out the area. So the area is pi r squared, which is pi times the radius, which was 14 squared. Which turns out to be 615.75 squared. 75 centimetres squared rather. So now I know the force, which is the weight, and the area. So the pressure just equals the force over the area. So that's going to equal the force, which is this 951,382 1.4 over the area, which is 615.75. So I'm now going to put that into my calculator, and now I'm going to round. So I get 15450.8 if I round it slightly. Now let's look back at the original question and look at the numbers I put in. 2 significant figures there, 2 significant figures there, 2 significant figures there. So it's probably appropriate to round to 2 significant figures. So let's look at this. This equals, if we think about 2 significant figures, that's the first and that's the second. So that's what I'm going to, and I look at this because that's less than 5. I'm going to call it 15, but then I need to fill in the zeros. 15,000 in other words. And what's a unit? Newtons for the force over area, which I measured in square centimetres. So 15,000 newtons per square centimetre. Or, if I wanted to use kilonewtons, 15 kilonewtons per square centimetre, and that will be the pressure. So hopefully, if you had a go at this, that's roughly the answer you got. You might disagree slightly because of roundings, but it should be that if you round to two significant figures.